which will be by John Pritchard about the P2 API. You can share the screen, John.
Good afternoon. My name is John Pritchard. I'm also a user support astronomer at ESO. So I'm going to talk to you today about the Phase 2 Application Programming Interface, or as we call it, the P2 API. Why do you need a P2 API? Well, because the P2 web tool, as we've just seen, is very cool. But what do you do when you have tens, hundreds, maybe even thousands of OBs to create? Or maybe complex observing strategies, lots of time intervals to put in that are difficult to define, need to be precise. There is an answer, rather than having to point and click and type things manually tens, hundreds, thousands of times. You can do this programmatically via the P2 API. What exactly is the P2 API? Well, to be precise, it is a REST API. It's based on the fundamental principles of REST APIs. And if you don't know what that means and you want to know, just go and look it up on Wikipedia or Google it, whatever it is. But it basically means it adheres to certain rules for software to communicate with each other. It is described in detail at the reference. Let me get the laser pointer going here. So at the URL there. So the P2 API is in fact the bit that's on the server side. So it's what in fact P2 uses to communicate with our databases. When you're working in P2, whenever you change something, that information is sent directly to the ESO database via the P2 API. So P2 is a web application that communicates with the P2 API, and via the P2 API, the database is behind it inside ESO. So the information that you can find here allows you to write software that can also communicate, just like P2 does, with the P2 databases at ESO. To make your life a little bit simpler, we also have developed and we continue to maintain a Python-specific binding for the API. It's available to you. You can get it from the ESO RPM and MacPort repositories, or you can get it directly from the Python package index, PyP. Just a few words of advertising for the MacPorts and RPM repositories. I can find the right button to click. So these are repositories that we have created at ESO, so they're hosted on ESO servers, but they can be easily integrated into your Fedora, CentOS 7, or macOS software via MacPorts, or directly via RPMs. You can find instructions on how to use them at this URL. But so in there, we support all of our pipelines and ESO Reflex, so the pipeline processing software. The P2 API, obviously, as I just mentioned. You can get the observation software preparation software from there for FPOS for Flames, FIMS for Force, and Karma for KMOS. There's also a couple of generic tools, including SkyCat and QFits, which is for looking inside FITS files with headers and things like that. And there is the specific tool for Force, FS Mosaic, which allows you to just stitch the two chips that come from a Force imaging observation together into a single image. So back to the P2 API. There is a step-by-step tutorial, again at the URL. To do.
Sorry, John. I think there was at least on my side, some connection issues, so I couldn't hear you for a few seconds.
Can you hear me now?
Yeah.
Okay.
Thanks.
Okay. It creates everything, it covers everything from creating OBs to creating time links and all the way through to submitting the phase 2 material for review. So you can do it, your entire phase 2 submission entirely programmatically. And if you really don't want to, you never have to touch almost never have to touch a web browser. So it is possible. And of course, you can get full documentation of the tool itself inside Python by typing help p2api p2api p2api.p2api. What else is there to say? We provide a few example pieces of software that have been written by mostly outside people. Well, mostly two out of the three have been written by non-ESO. Not true. 1 out of the 3 has been written by non-ESO staff. The others, so one is FC Maker, which was written by an ESO fellow at the time. He's moved on to greener fields, but so that was the origin of P2FC, which is now integrated into P2. There is a script for uploading the OBX versions. Those of you who are familiar with the older version of P2, P2PP, you are able to export your OBs into a text file format. This is called OBX. This is still possible in P2. So you can export OBs and OBX, you can manipulate them, or you can even create them directly if you know the format well enough, but you can export them from P2, manipulate them using standard tools, or even edit them in an editor if you are careful. And then you can upload those files again into P2 using the OBX import script. And it's even clever enough to reproduce folder and container structures. And finally, there's a third example of how to upload PAF files, which are files, essentially all of the external tools that generate setups for the instruments like FPOS and Karma. These produce PAF files which get attached to the OBs and are then used at the telescope. So there is, as I say, several examples if you want to learn how to use it by example. Finally, an important point to mention is all about etiquette, just before I go to an online example, a demo. You should remember that you're talking directly to the ESO database. So in order to keep the operational database clean, we ask that you do all your development and testing on the demo database. And there you can create as many OBs as you like, and you'll see in a minute there's plenty of testing going on and creation of OBs and whatnot. And once you have your procedure worked out that makes the OBs that you want it to make, then you can run it on the production server and actually produce the OBs that you then submit as part of your phase 2. There's just one thing or two things to remember when you do that. The OBs in P2 demo are public, so anybody in the world can see them. So don't put any private information there or your super secret target, that kind of thing, because if somebody wants to, they can see it. And the other thing is that from time to time, we simply clean up that area. So if you put something there, it may disappear 5 minutes later, or it may disappear 6 months later, or 5 years later, but eventually it will disappear. So it's not a permanent storage by any stretch of the imagination. Okay, so having introduced the P2 API, I'd like to make an online demo of it. So let me switch now from sharing my presentation to sharing my desktop. So this one. Okay, so to use the P2 API, indeed, you sort of need to start at the web page. So let me go to P2 demo to begin with. Go straight in. Then if you go to, well, let's first install the software, shall we? So let's go first to the Fedora case. So here I have a Fedora 32 virtual machine. It's really easy. You use DNF and you can search for P2 API. And if that doesn't take too long, that's going to take too long. Okay. I just noticed preparing this demo that I made a copy and paste when I prepared the package, and it's still talking about Astro Scrappy in the description, so I need to fix that. So that'll be done in the next day or two. But the package we need is here. On older systems such as CentOS 7, which don't yet support natively Python 3, it'll be Python 2 rather than Python 3. So we can now sudo dnf install. Let's copy and paste, enter. So it's easy to use, at least to install. After that, it's just a question of doing Python programming. So as usual, it wants to install the package we've requested, P2 API, plus the dependencies. Click yes, and away it goes and installs those things. And before you know it, it's done. Okay, and then just to show the same thing on Mac, here we have Mac ports, so it's sudo port install. Here the package is, well, again, we can do a search, P2 API. We get a whole list of them. So there's a version for each version of Python that's supported from Python 27 through to Python 39, 3.9, I should say. So let's install Py 36 ISO Python 32. There we go. While it's doing that, just to show that it's really working, we can come back here and actually just try and use it. Import P2 API. If I can spell it properly, P2 API. Yay, it works. And this to show, there it is, it's installed in userlib, blah, 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 blah. So that's working under Linux here, back into the Mac ports, back into Mac OS. It wants to install a bunch of packages. So yes, of course, we'll do that. Install all those packages. And we'll have the P2 API installed under Mac ports. It's going to take a little while. We'll leave that running. I can also demonstrate how to install it in the case you use Conda. So in that case, if it's not activated by default, activate Conda. We can create an environment specific to it. Let's say using Python 3.9. We create an environment in Conda. We'll call it P2 API, and we'll use Python 3.9. Make the installation. Let's see, there we go. It's finished installing in Mac ports. It's all very simple. It's also created the basic environment for Python 39 in Conda. We can activate that environment now. Conda activate P2 API, and then we can install the P2 API package direct from PyP, i.e. via pip, Python -m module, the pip module install P2 API. There it is, it's installed. That was quick. So let's check that it's working properly. Start Python, import P2 API. Yes, that completed without error. Okay, we can do a quick few things based on the demo, which you can find online. As suggested there, it's nice to use pprint, pretty printing. So the important thing is first we import P2 API, and then all the action happens by creating a connection to the P2 API. So by convention, we call it API, the module P2 API, and we want an API connection. This takes 3 parameters: the environment you want to connect to, the username, and the password. If you want to, when you want to actually put this into production, into the real OB repository, you specify the environment production. If I can spell, it comes up like that. If your program is at LaCia, there's a slightly different environment, which is production underscore LaCia. But for all of our testing, we should use demo. Put demo. And on the demo server, we use the tutorial account, which is 52052 with the password tutorial. This is all on the web page, the demo, the tutorial that's on the web pages that you can follow in detail. Then after that, essentially all the commands that you might ever want to use to get information or to set information are prefixed by API. So for example, to get the information about the user that's logged in this case, the tutorial user, you type api.getUser. And it returns a bunch of information about that user. So the username, first name, etc. Very quickly, if you follow the tutorial, it will tell you to go to the P2 demo website, and it will tell you to load or to go to the UVis service mode folder and open it. If you do that, you'll find that there's already a lot of folders that people have already made to do this. So instead of using that one, let's use one that's much less populated. Let's use the Amber one, which only has one other folder in. We need to know what is the container ID of this top level container, the run that we're going to work in. So we click on that and we get from that here container ID, which is just this number here. We copy that, and then over here we can set do that, and we'll set that to a variable called run container ID. And then let's create a folder which we'll call the LPO Users Workshop tutorial. So we have here, because I know how this works, I know that this function is going to return 2 pieces of information, an object called a folder and a folder version information. And to actually do it, again, of course, I say API, and then the function, the method I want to use, create folder, the container that the folder is going to be created in, and the name of that folder that I want it to give. If we come back to P2 demo and we close and open, then we see, lo and behold, there's the folder we just created. So just to explain those two, now this structure whereby a command returns 2 pieces of information is basically used for all of the commands with the P2 API, or at least the Python implementation of the P2 API. In general, if you're creating something, it will return the structure of that thing you created. And the second piece of information is the version information. And that version information is important if you then want to go back and modify that object. So for example, if we come here into P2 and we say, I don't like the name of that, I want to call it my LPO. If I can spell again, there we go, change the name. Okay, now here back in the API, I decide I want to change that folder. In fact, I want to delete it. So the delete API for folders is api.delete container, the folder ID I want to delete, and I have to give it the folder version. So if I now try and delete it straight away, it fails because I didn't set folder ID. So let me first, let me print the information about folder. So the folder, the original information returned is just a Python structure that contains all the information about it, about that folder. So its ID, the status of it, how many items or OBs or other folders or containers that are inside it, its type, it's a folder, its name, and its parent container, and the run that it's associated with. So all of this information. So I want, in order to interact with this folder, I have to reference it as I have to reference its folder ID or container ID. So in this case, I set the variable folder ID to that. Then I can try and delete it. So I want to delete the folder whose folder ID is the one we just created, but that fails. And the reason that fails is because of this version information. When I went here and I changed the folder, it changed the version. And so this is a safety mechanism to make sure that you're getting the latest version of the software, of the object when you try and modify it. In order now to actually delete it, I simply have to fetch the folder information again. So I refetch the folder information with, instead of the create container, I now just do get container with the folder ID, again setting the folder and folder version to the returned information. And then if I now try and delete it, now it returns successfully none, none. And if I come back here and reload that folder, the folder has disappeared. So this is the basic way in which the P2 API is used. You create a connection with the first command that I showed, this P2 API connection, API equals. Then you interact with the database, creating objects, manipulating them, changing them. And almost all of the commands have the structure of returning two items, the structure itself and the version, which then allows, you can then use in the next command to modify it if you want to. There's lots of examples. In principle, everything that you can do from the web interface, you can also do from P2 API. As I mentioned before, both the Python binding and P2 are actually talking to the same P2 API, the same server software. So everything should be enabled. It's just sometimes the Python bindings get a little bit out of date and not always up to date when new features are implemented in the API itself. I think I should probably stop there. I'm already over time, and hand back to Tommaso.
Thank you so much, John, for the presentation and for the tutorial. So this was the last presentation for today. So now we are open to questions. So if you have any question, you can either raise your hand or write it in the chat. There's one from Marina.
Or maybe just to follow on the John's example tutorial, use of API, where would you see the most practical use of the API? Of course, it's something that requires a little bit more deeper understanding of the structure of the databases and the content of the OBs and how it's split, actually. So where would you actually see it as worth investment of the time? Let's put it this way.
I think it depends on what kind of person you are, but basically it corresponds, depending on who you are, to a certain number of OBs. I think for me personally, it would correspond to about 10. If I had to prepare more than 10, I'd start using the API. And it depends how similar and how different they are, and how much it can be standardized in terms of writing things, and how, I mean, obviously, if you have to do a lot of interaction with ObsPrep, the P2 API is not going to work, because you can't use ObsPrep in the P2 API. You can put all the information that ObsPrep generates via the P2 API, but you can't do the pointing and clicking. For other people, maybe it's 100 OBs before it's worthwhile resorting to P2 API. The other case that I have from my own specific use point is if you have, for example, if your observations are of a periodic phenomenon, an eclipsing binary, for example, and you need very specific time windows, and there's maybe tens or hundreds of them during the period, typing all of those in would be somewhat tedious. And so the API could be used to do that, to automate that procedure. When I was doing the science myself, I already had software that predicted, or that I could calculate those intervals. And so now, remembering what it was like back then, well, back then we didn't even have absolute time intervals integrated. You just had to put them in the README. So that was easy. I could copy and paste into the README. Now I would use the P2 API to take the output from that program and to automatically add those time intervals into the OBs themselves. I mean, it's useful when you have large numbers of repetitive tasks or tasks that would require a lot of typing that is error prone. I mean, that's where it can help you. When you have the information from one source and you've got to get it into P2 and you want to avoid the possibility of errors by typing and things like that.
There's one question from Roland.
Yeah, I think John just brought up a good point in the sense that you don't need to think of using the P2 API from starting with nothing for your OB. You can start off with a perfectly valid OB that's just missing some bits and add those bits with the API, like the time windows he suggests.
Very good point. Yes, you can prepare things manually, then use the P2 API to finish it off the OBs or add the details as necessary, indeed.